solubility of gas in, in liquid solvents, and also we have discussed about the solubility of liquid and the solid in liquid solvents. So when we have discussed about the solubility of gas in liquid solvents, in that case we have come across a rule called Henry's law. Okay, so Henry's law. There is the Henry's law. Okay. Then we have come across the law called Raoult's law. What does it say? It is the partial vapor pressure of the solution is equal to the product of vapor pressure of the pure solvent, pure component and its mole fraction. So it is like this. P is equal to P0 and chi. So this is the one. Okay. Now it says that Raoult's law is a special case of Henry's law. So it's very interesting. This is for what? Solubility of gas. I told you if you don't understand, you ask me. But till now, none of you have asked me a single question because it seems that you are extraordinarily brilliant. Solubility of gas in, and Henry's law is applicable for what? Henry's law is applicable for the solubility of liquid or solid solute in. Now how to compare? It says Raoult's law is a special case of Henry's law, but we have to prove. So we can write now again, say I have already written that Henry's law is this and Raoult's law is this. Now this is very interesting. In Henry's law, when I dissolve a gas into liquid, which one comes first? Which one comes? It is the gas which dissolves there, it comes out, not the liquid solvent. When you open the bottle of Sprite or any other cold cold drinks, you find moment you open, the liquid does not come. The gas bubbles of the gases comes out. Okay, so which is more volatile? The gas is more volatile. And in case of the other solution, which is more volatile? It is the solvent which is more volatile. So what we can write now here? So Henry's law, we can write it here. Raoult's law, I can write it here. Okay, let me write here. Henry's law, P is equal to A into chi. So what is chi? Yeah, chi is the mole fraction of gaseous. And Raoult's law? Yes. What is the chi here now? It is chi here is mole fraction of the. So now we how do we get right now? See, this P is, in this case, this P is the vapor pressure of the component. In this case, P is the vapor pressure of the gas. All right. Now, how to make them equal? See here, both of them are same. This is also same. Then when this equation, when can you say Raoult's law is exactly like Henry's law? In Raoult's, we can say only when that Kh is equal to P0. So what we write now here? In Henry's law, the volatile component is the gaseous, while in Raoult's law, the volatile component may be either maybe any component is either solvent or solute and solvent. Why? Don't get confused. Why should not get confused? Either solvent if the solute is non-volatile solid, like sugar in water. Sugar does not go out. Here, solute and solvent means if I have dissolved ethanol in water. So this is the one. Okay. Now what we can say, how to make them equal? So we can say, we can write that Raoult's law can be equal to Henry's law when, not when, only when only when Kh is equal to. This is important for your exam. In my note, I have written it very clearly. So please read.
Done, sir. Done, sir.
Okay. So now we'll go to a new portion, which is called ideal and non-ideal. Ideal and non-ideal. See, this word ideal has created so much of problem in your life. Do you agree with me? Hmm? Hello, do you agree?
Yes, sir.
Because every now and then you are being given example of a real or imaginary student who is ideal. Huh? You have not seen that person, but you are being compared. It can be your neighbor's son, or maybe a visionary people, or maybe a very distant relations children. Every time you are being given an example, is it not? Hmm? Hello.
Yes, yes, sir.
So what is an ideal object or ideal principle? Ideal object or ideal principle is supposed to match with all the requirements which is necessary for its setup. Okay. So what is an ideal solution? Ideal solutions are those which obey Raoult's law at any concentration and at any temperature. So this is called an ideal solution. At all temperatures. Now, what is an ideal solution? Hmm? An ideal solution. So for a binary solution, what will happen? For a binary solution of two volatile components, क्या होगा? See, now we know So PA would be equal to PA0 IA and PB equal to PB0. This is the condition. So it has to be like this. Okay. So please remember. So any solution which obey this rule, they are called ideal solution. Pressure of solvent and solute. Write down.
Okay,
Write down where you write. I'm telling you, write down. Where PA and PB are the partial vapor pressure of A is solvent, huh? Of solvent and solute. Right. Solvent, sorry, right. Solvent and volatile solute respectively. Solvent and volatile solute respectively. Then put a comma. Right. PA0 and PB0 are the vapor pressure of pure solvent and solute.
sir, can you repeat again?
After comma, you write PA0 and PB0. PA0 and PB0. See PA0, 0 the top. This is subscript, this is superscript. PA0 and PB0 are the vapor pressure of pure solvent and solute. Okay. Then again write comma. Right. Chi A and chi B. Chi A and chi B are the mole fraction of solvent and solute. Chi A and chi B are the mole fraction of solvent and solute respectively. Okay, now see here. So just on the top of this, you have written no? Here you write. I forgot to write this one. Please write. Conditions for an ideal solution. This is one more. Okay. The second, so this you have already written. Now, what is the second? See here. No change in heat in the no change of temperature. No change of temperature takes place. Means it, that is, neither heat is evolved. That is, what should I write here? Minus delta H. Nor heat is absorbed. Okay. Therefore, delta H solution, no change of temperature, it is equal to 0. Then what is the third condition is that if I tell you, then you may laugh. See, suppose I have added 30 ml of ethanol in 70 ml of water. What is the total volume? I have added 30 milliliter of ethanol in 70 milliliter of water. What should be the total volume?
100.
100 ml.
Correct, perfectly correct. But in solution DI it does not happen. In some cases, it may be less than 100. Some cases, it may be more than 100. But in ideal solution, it will be always equal to 100. So, what should you write now? The total volume of solution is equal to the sum of the volume of solute and solvent. Means whatever volume you thought, exactly it is like this. So what should I write now here? Delta volume solution is equal to 0. It is neither less than the total volume expected or more than that. It will be 30 plus 70 is 100. There's no change in the volume. So these are the three conditions. You have been in your school for such a long time. Each school you have almost stayed for 8, 9, 10 years. So you have so many classmates. You have so many friends. But how many of them are very close to you? How many of them? Who's that? Who is your best friend? How many? See, best is always one. Huh? So how many are friends are there who exactly thinks like you? How many are there? Hello? Do you have many?
Few, sir.
Very few. Why they are few? Because they can be like you, they can think like you, they can act like you, they can feel for you only because their background and your background, family background is almost same. Okay, only in Hindi movies you find that a farmer's son has got a very close friend who is the daughter of a very rich person. It is not possible. Absurd. Okay. So let us see. What is the condition for a solution to be ideal? Oh. So what we can write first? First of all, we will write no solutions are ideal. It is nothing is ideal in this world. Or we have already talked about the solid state. We have talked about the crystal structure. But what did you find? What about the crystal structure that you studied then in theory, in practical is not matching? So when it does not match, what you say? Of course, this crystal would have been ideal if it would have been at 0 Kelvin. Till now, we could not achieve 0 Kelvin. So it is an imaginary thing. It is an imaginary thing. See, almost all of you are religious. You may belong to different religions. You may belong to Christian background. You may belong to Hindu. You may belong to Islam. You may belong to anything. So right from childhood, we have heard about religious preaching. So many things about religion. When the priest who is telling us, he also did not see God. He also did not see the God. Okay, so it is a simply a hypothetical value that God is there. Okay, but none of the person has ever seen God. So it is a hypothetical. So we are being told you may not see the God, but try to follow those dictates or the rules laid down in our religion. Okay, so we also go for it. Similarly, all the conditions that you have written down, hardly any substance follows. Okay, so you cannot have 100% ideal solution. But as we can pretend that we are religious, we follow all the commandments given by our individual religion. So here also I can say that if the solute and solvent that we are taking, if they're almost alike, then their solution will be behaving like a ideal solution. Just like that, if you do not have any differences of thinking with your friend, then both of you can think alike. But some places you may differ from your friend, but the difference will be so slight, so less. At least you can say that both of them have the same thing. But nobody is giving their opinion by the force of other. Nobody is influencing me. So we can write no solutions are ideal. Now, a solution can be ideal only when the components have almost similar components have almost similar structure and exhibit same intermolecular forces of attraction. They should have, if you take the example of human being, in that case you will find they should come from the same background and their upbringing also should be same. See, in our country, our country is a secular country. In that case, we should, if you respect each other, then there cannot be any quarrel with the religion, cannot be quarrel with the language. But why still we are having it? Because somehow we are being taught that try to behave like Hindu, try to behave like Christian, try to behave like Muslim. No, we are supposed to behave like human beings. See, we have come to religion by default. If I born in a Hindu family, I am Hindu. God did not dispatch you from his place that you go and born as a Hindu, you go and born as a Christian, you go and born as a Muslim. Okay, but you will find in your house, if you respect all religion, all faith, all language, irrespective of any community, you'll find you can also have a true friend from other communities. That is the thing now is happening, missing in our country, and people are fighting with it. It's very sad, very sad. First of all, we are human being. Religion comes second, language comes second. We have to prove that we belong to Homo sapien. First, behave like Homo sapien. Okay. So, solutions can be ideal only when the components have almost a similar structure and exhibit same intermolecular forces of attraction. Okay, I'll write down some common examples where the solutions show almost ideal equilibrium. Okay, so their structure almost should be same. See here, it is a mixture of benzene. Okay, see here, benzene and toluene. See, almost same structure. Only one extra methyl group is there. Then carbon tetrachloride and silicon tetrachloride. See, just below carbon is silicon. So it does not differ so much in their property. See, hexane and heptane. See here, hexane has 6 carbon, heptane has 7. Only one CH2 group is extra. 4 ethylene dibromide and ethylene di, etc.
Done, sir.
Non-ideal in non-ideal solution, what will find? These solutions do not obey Raoult's. What is Raoult's law? pH equal to pH 0 chi. So what we should say that the vapor pressure of the solution, vapor pressure of the partial vapor pressure of the component is not equal to the product of partial vapor pressure of the pure component and its mole fraction. That is, you can say that partial vapor pressure the partial vapor pressure of the component is not equal to the product of vapor pressure of pure component and its mole fraction. Okay, that is you can write that is PA is not equal to PA 0 I. Yes, please remember. Okay, now second, the heat of the solution delta H solution is not equal to 0. It can be either more or less. Whether more means what? Positive, or less means it negative. Positive means it absorbs it. Negative means it gives. And third, volume of the volume change. Please do a little correction here. Heat change. The volume change yes, of the solution delta V solution is not G. It can be, as I told you, 30 plus 70. It may not be 100. It may be less than that or it may be more than that. So these are the conditions for non-ideal solutions. solutions can be classified into two categories. Two categories. A. Non-ideal solution with positive deviation from Raoult's. Negative deviation with Raoult's. Now, in non-ideal solution positive deviation, what will happen? Right? In non-ideal solutions, when the vapor pressure partial vapor pressure in non-ideal solutions, when the partial vapor pressure of the component is components are more than the product of vapor pressure of pure components and their mole fractions. Don't get scared by so many words. I'll write in just one equation. It is PA is greater than PA0 IA and PB is greater than PB0. in non-ideal solutions. Where? Heat change. Heat change of the solution delta is greater than 0. Or what? Positive. Volume change of the solution Acha, I'll do little change. Yeah? In your book, they have not written solution, they have written mixture. Okay. So you may get confused that Sir is writing something which is not given in the mix. Mix means mixture. Is greater than positive. These are all theories. Okay. Now you know, you can immediately identify why this is happening. Going to happen. Okay. Then I'll give you a very simple example. Say you are going to one place from your home and you have taken a shared taxi. So other passengers are not known to you. So when you do not know them, obviously you do not go and sit closer to them. Okay, we must keep some distance between the passengers. Okay, but if three of your friends is sitting there, in that case you will find there will not be any gap with each other because you know them, you like them, so you have come closer. Why the volume, as I told you, 30 plus 70 is not equal to 100? If the solute and solvent, they don't like each other, they maintain a distance from them. And as the distance increases, total volume of the solution increases. Okay? And I told you, when you mix a solute and a solvent, there are three types of attractions are there. Because solute molecules have to be separated from each other. Solvent molecules have to be separated from each other. Then they will mix with each other. And after that, a new interaction will develop between solute and solvent. See, if the solute and solvent interactions are weaker, means what? The previous interactions are strong. So in that case, those type of solutions will give you positive deviation from the ideal solution or Raoult's. Okay. So why in the vapor pressure of the compound has increased? Because somehow they want to get out of this situation. How a liquid solvent will get out of the situation? It cannot jump out. It will try to evaporate faster and faster. So in that case, it has to increase its vapor pressure. So the vapor pressure becomes now more than equal to the vapor pressure of the pure component. Okay, so we'll write now. This is the theory now. Solution in which solutions in which the previous interactions means what? solute solutions in which the previous interaction, that is solute and solvent are stronger than the solute and solute then the solute solvent interaction show positive deviations from rules. This is the conditions. So let us take some examples, then I'll explain. Examples. Anywhere you don't understand, you ask, huh? But I'm very lucky to teach you because you are so wonderful. Anything I speak, you understand. Solutions showing positive deviations. Okay, so I'm right now here. Acetone, I think this formula you already forgot. Okay, I'll write. You give me ethanol or methanol. Because if the example is changed, then so you will say, sir did not tell me. Again, I'll write the formula. Acetone and carbon disulfide. What is the formula of carbon disulfide? Carbon dioxide is CO2, carbon dioxide is carbon CS. I don't think I have to write the formula of water. Water and ethanol. I have already written ethanol. Carbon tetrachloride, CCl4 and toluene. CHCl3, chloroform. See, so many examples I'm giving for your entrance exam. Acetone and benzene. You know the structure of benzene? Till I draw. Cyclohexane and ethanol. Benzene and ethanol.
So what is the formula for chloroform?
Chloroform CHCl3, CHCl3. I've written, na?
Yes, sir.
I will draw a graph. How does it look like? Then after that, I'll discuss an example. Okay, see here. Yesterday, I have drawn a graph. I'm not doing it very big. Okay. Okay. This is PA0, PB0. Here, chi A is 1, chi B is equal to 0. This is pure. This is pure. And this is 0, pure. And this is chi B1, chi A 0. And this is what? Mole fraction. And this is what? Hepar. This is also hepar. My handwriting is not clear here. Okay. Now what is this? Yeah. P is equal to PA plus P. And what is this? PA is equal to PA0 phi. And what is this? PB is equal to PB0 phi. This is for ideal solution because it follows Raoult's law. with the positive deviation. See here, what is going to happen here? In case of positive deviation, now we found that vapor pressure is more. What will happen now? See, this is the actual one supposed to be. Now this vapor pressure has become. I'll remove this one. This is hypothetical, and this is the. What do you find here? P, sorry, P is more than PA plus PB. Okay. This is the theoretical one. What did you find? Just become like this. What should I write down here? PA is greater than PA0 type. And what is this? Please draw a little better than me, huh? Please excuse me for my bad handwriting. Oh, I'm sorry, dear. It is PB. I'll draw it again. This is one too clumsy. Okay. So what should I write now here? This is for PA. This is PB. And this is here you will find PA is greater than PA0 and this is PB is greater than PB0. No. Last time I made the same mistake. And this is what? Non-ideal solution with positive deviation from Raoult's law. Generally, we do not say such a long one. We say non-ideal solution with positive deviation. Or what we say? Positive deviation, non-ideal solution. Sorry. Example, okay. What is this? Benzene, ethanol. It may be benzene or cyclohexane. Okay, I'll write down below. Okay, see, before I have mixed them, how do the benzene molecule exist? Benzene molecule exists by, what is the force of attraction in benzene? It has dispersion. I believe you remember dispersion force till now. Hello? Interesting. Do you remember dispersion force?
Yes, sir.
Yes or no?
Yes, sir.
Acha. Then Miss Gitanjali Pal, you remember dispersion force?
Yes, sir, Udit.
Huh? Gitanjali, do you remember dispersion force?
Sir, little bit.
Little bit. Taratara samne ami pai. In which type of molecule you will find dispersion force? Which type of molecule shows only dispersion force? Non-polar molecules. Little bit, na? For example, the COVID, I do not know. I'll go to your house. I'm more than COVID. I'll simply go and break your head. So, what are the interactions it has? Ethanol molecule is a polar molecule. Okay. Interactions. It has two interactions. One is dipole interactions. Dipole interactions are stronger than dispersion force. And second, strongest one is what? Hydrogen bonding. Hydrogen bonding. See, now I'm going to mix. In solution, what is supposed to be there? Solute molecules should come in the solvent molecules. It is first they will break their relationship, become individual molecule. Then this molecule has to break that. So what will happen? This is the, say it is solute and this is solvent. Now we will have solutions. See, now the solution has taken place. Solute molecule has come in between the solvent molecules. See now, hey, how much time is required for cooking and how much time is required for eating? Where do you require more time?
Cooking requires more time.
Ah, very good. Can you cook? Huh? Hello.
Yes,
Reply
sir.
that. Huh? What is your name?
Grace.
Hmm?
Grace.
Very good. Where you have to spend more energy, cooking or eating?
In cooking only.
Yes. See here. So ultimately, if suppose you know how to measure the energy. You have measured the energy that is required from your time you can find from your watch. If you want to measure the energy, then suppose you have measured the energy that you have used for cooking, and you time time that you have used for eating. Which energy will be more? Cooking. So in that case, what? That is, you have put more effort to cook than to eat. See here in this case, when this molecule has made the solutions, first of all, they have disintegrated, they have come separate. Then such strong bonding between them, you have to separate. That is, you have to spend more energy. After this thing after the solution is being made, see, alcohol and benzene, this is polar and this is non-polar. So in that case, you will find attraction is less. Okay. Suppose you are given an option to go to your friend's house and to your mother's friend's house. Where you will go? Which place you will go? Suppose the option is being given that you want to either to go to your friend's house or to your mother's friend's house. Where you will go?
Friend's house.
Friends house.
Because if you go, you feel comfortable. In mother's friend's house, you will not be that comfortable. So see in this case, this is the new relationship. In this new relationship, the attraction between the molecules are weak. If the attractions between the molecule is weak, will they come close? They will not come close. Suppose you have added 30 ml of this and 70 ml of this. 30 plus 70 is supposed to be 100. See, now these molecules are not close. So the volume of the solution will be more or not? The volume of the solution is more. So here 30 plus 70 will not be 100, will be more than 100. And moreover, you have spent more energy to break these molecules. Break the relationship. The new relationship that you have got, this relationship is weak. So in that case, you find the energy involved in this process, this energy involvement process is more. So the process is endothermic. It is heat is absorbed or delta H is positive. So such solutions always show the positive deviations from ideal behavior. So I'll write down now. In the solution of benzene and ethanol, the previous interactions, that is solute, solute. In your book, what they have mentioned, solute, solute, B, B. And solvent, solvent means A, A. Is more than solute, solvent, AB. Okay? So, these molecules will not come nearer to each other, leading increasing volume. That is what? Delta V mix is more than 0 and will absorb heat. It is delta H mix is 0 or positive. Hence, the solution will show positive deviation from Raoult's